are still longing to come and join us. Welcome to the June issue of the Canadian Transfusion Trials Group Research Methodology Lecture Series. And this month, we are very honored to have Dr. Shane English joining us. Shane is an adult intensivist and neurointensivist and an associate professor of medicine and critical care at the University of Ottawa and associate scientist at the Ottawa Hospital Research Institute. He did his undergrad medical education at the University of Ottawa, his internal medicine training at the University of Calgary, and then returned to Ottawa, where he served as chief resident and completed fellowships in general internal medicine and adult critical care, with a particular interest in the neurocritically ill. He's pursued fellowship training in neurocritical care in the UK at Cambridge University Hospital's Adam Brooks Neurocritical Care Unit, and subsequently completed an MSc in clinical epidemiology at the University of Ottawa and the Royal College of Physicians and Surgeons of Canada's clinical investigator program. And as many of us know, Shane was also the first author on a very important randomized controlled trial of different transfusion thresholds for patients with subarachnoid hemorrhage, which was published in the New England Journal of Medicine in March. It was an impressive trial protocol in its scope. I believe you enrolled patients from 23 centers across Canada, the United Kingdom, and in Australia. And just the logistical challenges of running a trial like that are quite impressive. And I think what we have asked Shane to speak on today is the process of piloting the protocol and lessons learned from that exercise that might inform our own research ambitions. And so with that, Shane, I'll pass it on to you if you want to share your slides and take it from here.
Perfect. Thank you very much for inviting me to talk today. I just want to maybe confirm that you are able to see a PowerPoint presentation in presentation mode.
Perfect.
Working
Yes.
on a few different screens here. So yeah, thank you for the invitation, Jacob. I appreciate very much the chance to speak. I have to admit, it's a topic that we talk a lot about within the trials group, of which I'm an active member, the Canadian Critical Care Trials Group, and that is piloting the work that leads up into a large randomized controlled trial. But when you actually do a bunch of reading around it, there isn't a lot taught. And when I think back to even my time in my ClinEpi courses, doing the masters in ClinEpi, there really wasn't a lot around the pilot RCT or pilot work. And so I've conjured up a few slides from various reviews that exist that I will reference at the end to try and put some, I guess, scientific aspects onto the talk. And then we will talk about a couple of examples, including the Sahara experience, and hope this addresses some of the questions you were hoping I might be able to talk about today, in why conducting a pilot RCT is worth it and how it lays the groundwork for future large-scale RCTs, ideally in a successful way. So I have no specific conflicts of interest to share from industry. I have received various grants from peer review granting agencies, largely national in scope, and those really are my only conflicts. So the goal is really to understand the purpose and scope of a pilot RCT, identify some of the key components and design considerations. I'll explore very briefly some methodological challenges and discuss some mitigation strategies around that. And we'll do that mostly in the context of a few examples and case studies, and summarize ultimately the benefits and limitations of a pilot RCT. And so what is a pilot RCT? Turns out a lot of people describe this various different ways. And so it really is a small scale test, or a mini RCT, some say, of the methods and procedures used on a larger scale in the future. Pilot work, as opposed to a pilot RCT, is really any background research that informs a future study. And these ultimately are preliminary investigations that are designed really with the specific mind of determining feasibility or safety or mechanisms that will be put into use within a future study. and that ultimately a well-conducted pilot trial giving clear list of aims and objectives that works within a specific framework ensures the methodological rigor that funding agencies ultimately are looking for in grant applications, and ensures that your work is scientifically valid and ideally publishable at the end, and at the end of it all leading to a high quality RCT that ideally will inform practice. A little bit different within industry, and we talk a lot about phase one, phase two, phase three trials, where phase one is classically the first in human study, usually healthy volunteers, and this is really looking at the effect of a new drug, usually on some surrogate outcome. Phase two studies are where we identify the therapies or look at different dosing regimens warranting further investigation. So trying to find the highest leading either drug and or dosing regimen of the drug that has some promising future within industry. Phase three are the larger than studies, the actual randomized trials comparing the efficacy of the new drug to an alternate or to a control or to nothing in some instances. And then phase four being kind of aftermarket investigations, usually non-randomized studies, surveillance studies that document experience. So most of these phase one and phase two are considered pilot studies, and when you're looking within the literature, are fairly robust, although there is publication bias and a lack of publication in these overall. What I'm going to speak mostly to are piloting of clinical studies and not the classic phase one, phase two studies in the pharma world. And so a pilot study, as I've already alluded to, then is really any background work, project, or of any study really of any various design, observational or quantitative, that informs future study on a given topic. Whereas a pilot trial itself really involves a randomization procedure. And again, I'll elucidate to it a little bit, but it varies in what is published in the literature. So pilot clinical studies or pilot trials, I'm going to categorize them in three different ways. So there's an external pilot, which is a standalone piece of work, an internal pilot, which is typically incorporated into the main or the larger RCT, and a vanguard study, which I consider a run-in phase. In my reading and preparation for this talk, I realized that people use these terms very differently across the literature, but I'm going to try and conceptualize it in these three categorizations and go into a little bit more detail. And so the external pilot study is truly standalone. The purpose of this is often around feasibility or testing procedures. It's really meant to inform the ultimate design of a future trial. It typically is unfunded or funded separately. Usually seed funding are what we're in pursuit of for these types of studies. We look at various populations or centers that may change in the future trial. It's not or shouldn't be powered to any efficacy or effectiveness. And classically, the data is not included in the definitive trial. This is truly a standalone piece of work. And we'll go through an example with the revised pilot RCT in a few slides. An internal pilot is really meant to be embedded within, and so it's embedded within the main trial. It's really an early testing of procedure. It allows for you to make slight modifications or refinements of a protocol that you think is ready to roll with respect to the full trial. And so minor adjustments can be made through the internal pilot when you're really ready to hit go. As I say, it's often part of the main trial, and so often will be part of the same grant, where an internal pilot will be built in. Some are separately granted, and I'll talk about the Sahara experience where it was a separate grant that funded the internal pilot. There should be stop and go criteria as it relates to some of the feasibility metrics that you are intending to test, or some of the refinements, and the go is really around if you have little changes that won't affect the interpretation of the results from those that are early enrollers versus those later in the randomized trial. And assuming then that there is minimal changes, the data is often included as long as it hasn't been breached with respect to either your randomization or blinding, if that is relevant to your trial. And then finally, a vanguard, and this is the one that I find is used most variably or described most variably in the literature, but I consider a vanguard as being an early phase of an RCT where it may or may not contribute data into the full trial, but is a true run-in phase of a study. The purpose of this is not to test feasibility or to refine your procedures per se, but to assess operational readiness. It can test your data systems or site training or recruitment of a specific site. It may generate data that ultimately is not included in the final data analysis, depending on whether or not a study, for example, continues on in a trial. But is really meant to have a pragmatic focus on the systems or the process and much less so on the clinical aspects of the trial. And we'll discuss the cycle RCT and how it used a Vanguard trial. So reasons for which we would conduct a pilot trial is really around four main things: process, resource use and management, and scientific reasons. So process is really a context where we're assessing the feasibility of the processes that are key to the success of a study. So it's looking at things like recruitment and retention rates, refusal rates. It's looking at the failures or successes of these, particularly when you predefine your outcomes as it relates to the future trial. It's looking at compliance or adherence rates to the interventions. It's an opportunity to really examine your eligibility criteria and whether or not it's obvious about who is meeting or not meeting, and whether the eligibility criteria truly zero in on a population of interest. It gives you the opportunity to understand if your criteria are sufficient or too restrictive. It really is an opportunity of understanding your study questionnaires if you use them, particularly if some of these are patient-reported outcomes or patient questionnaires, and whether or not they're answering appropriately to the questions being asked or being left blank or providing too many answers. So it really is an opportunity to refine on some of these processes. With respect to resources, this really deals with assessing time and the resource problems that can occur in the future trial. It's about determining capacity and whether or not your team is ready for either the screening procedures, the enrolling procedures, or really the data management as is required in the case report form. We also really want to understand a center's commitment to the study and whether or not the investigators, whether it's the research team, whether it's the PI, truly have the time to perform the tasks that they've committed to do. And so particularly when the intervention is significantly involved or the data is timely in its capture with respect to not being able to retrospectively catch it in the patient record. It really is an opportunity to assess their engagement, their understanding of your case report form, and their timeliness to getting these data to you and to the organizing center. With respect to management, this is really covering the potential for human or data management problems. And so this, in my mind, is really around your, again, case report form and how your personnel interact with it. Are they encountering problems with entering the data, whether it be in a paper format or in a computer, like in an electronic version? Are the data that's coming from different sources, so either different systems or different healthcare systems, can you match and tie these together for one set of variables? And then if you are using electronic records or automated processes with which the data is being captured, can this be linked together with other data sets from various means? And then finally, with respect to scientific considerations, this is really dealing with the assessment of treatment safety or dose response, its effect and or variance of the effect. And so if it's unclear the safe dose, whether or not there's a dose escalation as part of your intervention, this is an opportunity to really understand the variance of that treatment effect. Feasibility is really, I would say, in the clinical studies, particularly the pragmatic trials that we tend to be involved in, and certainly the experience of the Canadian Critical Care Trials Group, is really around informing the feasibility. And so I've already alluded a bit to recruitment and consent and retention rates, but this is really important as it helps determine how long your study may need to be funded for, or what you might anticipate as being the duration of the overall trial, or the number of centers you may need to recruit to achieve the appropriate recruitment and consent rate. The integrity of the study protocol is obviously key, such that if you have an intervention that isn't appropriately delivered or is delivered differently across various centers, you ultimately are not going to be answering the question you've set out to do. If drug preparation is part of your study, this too will be an important measure for feasibility design and testing, so as to ensure that that drug is administered according to protocol. With regards to examining your eligibility criteria, we use the pilot to test the impact of your proposed inclusion and exclusion criteria. We in the Sahara trial, and I'll allude to this a little bit later, used the pilot to really develop our logs and our screening logs. So to really understand how our eligibility criteria were being applied by the research coordinators at the various centers, and what and why patients were being excluded, or what for and why patients were being excluded or overlooked or missed. It really gives a window, I think, to the recruitment potential of a various site and how you can maximize the potential for enrollment, or identify centers that perhaps just don't have the population you're interested in, or the resources to identify said patients. There's an opportunity to modify the procedures, modify your eligibility to truly enhance both the generalizability of the trial and the recruitment into the larger study. As it relates to assessing mechanisms, surrogate outcomes are often used in pilot studies to inform decisions for the future or larger trial. Clearly, a pilot study cannot be powered to clinically meaningful outcomes. It's not the purpose of it at all. And so this might be used as a proof of concept or a proof of safety to improve the buy-in amongst centers who will be participating in the larger trial. The caveat to this is that the results of analyses that are based on surrogates really need to be interpreted with caution, and arguably perhaps not even reported in the context of the pilot RCT, so as to not jump to erroneous conclusions about the efficacy or safety of a certain intervention, whereby affecting your recruitment ability and equipoise within the population or the centers you're hoping to work with. A couple of methodologic considerations. So it's really important to have explicit objectives that are standalone. So these objectives are very clearly different from the larger trial, and really center around the goal of the pilot, often feasibility related. Testable hypotheses around these recruitment or feasibility measures should be set a priori, with the intentions of what is deemed or what you will deem to be a successful pilot a priori. Failure to meet any one or more of the feasibility objectives really should provoke then either changes in your protocol, may affect who participates in the larger trial. So it may identify centers that are just not able to participate in the larger trial, or ultimately, and in the worst case scenario, may cause one to just abandon the stream of inquiry entirely. When setting out the pilot RCT or the pilot protocol, having corrective actions that are thought of and anticipated based on the findings of the feasibility are a strength to an application. And I would say to a reviewer who is seeing that you're already anticipating where some of the challenges may be and how you will use the results of the pilot to inform and ensure the success of the larger trial. The need for the calculation of a sample size in a pilot trial is highly debated. It really should not be derived based on estimated effect of an intervention on a clinically important outcome, but rather should be targeted towards ensuring that you can determine or establish feasibility of whatever it is that you're trying to determine. So it's based on the specific objectives and the outcomes that you've set out for the pilot. You may want to consider the need for multiple centers, and these feasibility metrics may be related to onboarding multiple centers, whether it's within one country or multinational. And that the rule of thumb is that the sample size should just be large enough to provide useful information as it relates to the feasibility metrics that you've set out for the trial, and doesn't necessarily need a sample size calculation. Some do it a bit differently. So Bram Rochberg, in the pilot of the fish study, which some of you may be familiar with, this is a fluids and sepsis and septic shock study that is looking at a high chloride or low chloride, so a balanced crystalloid versus unbalanced crystalloid resuscitation and septic shock. They conducted a pilot trial with the primary feasibility outcomes of consent rate, looking or deeming success to be a consent rate over 70%. They wanted to show that recruitment could be successful across many centers, and so they established a sample size of 50 patients for 3 centers with the goal of demonstrating at least 1 patient per center per month to be included in the study. And they also looked at protocol adherence to ensure that the study fluid of intention was being administered, and again set a target of over 75% of the intended fluid to be administered throughout the ICU stay. They established a sample size looking at the confidence limits then based on this protocol adherence, with the mindset that feasibility threshold, so anything above 75%, they felt demonstrated the feasibility of administering the intended fluids. They expected an adherence of over 90%, and so did a power calculation or a sample size calculation using a power of 80% based on this observed adherence of 95% and wanting to exclude anything lower than 75% adherence with a confidence limit, and as such set a sample size of just shy of 50 patients and use this in the justification of their sample quite successfully, and were successful in receiving national funding to do the pilot study. As it relates to the analytical plan and resulting reporting, again, it's very important to have all of this predefined. You want to specify your primary and secondary analyses as it relates again to the feasibility, not to the clinical outcomes. And that feasible objectives or feasibility objectives are really focused on whether or not you've met or not the objectives set out for yourself. When it relates to mechanistic objectives, the focus is really on the surrogate endpoint, whether it's physiologic or biochemical or some other surrogate. But again, caution really in how that is analyzed and reported, and should be mainly descriptive and often in aggregate. If you plan to report the results, to have an explicit strategy a priori of how you're going to do that and how you're going to prevent overinterpretation of underpowered results. Things you might consider would be reporting this still blinded, so group A and group B, as opposed to the actual intervention versus control, or reporting them in aggregate as a single cohort and describing variance in each of the outcomes. As it relates to the feasibility outcomes, having a stop, go or no-go strategy that may be a little bit more elaborate than just one or the other. And so stop is obviously the worst outcome. The main study just will not be feasible. And I would suggest very restrictive outcome measures or goals, if you will, to define stop. But more importantly, how you can identify these sort of middle two, these warning groups of how you might modify your protocol to ensure the feasibility of the larger trial. And this might be large modifications. This might be feasible with just very close monitoring and adaptations in the full trial itself. Or if you're lucky, continue without any modifications and is a go. As it relates to the reporting, this paper by Aaron, about 15 years old, I guess now in BMC, there's a series of papers that looked at the reporting of feasibility or pilot trials. This group looked at the pilot studies that had been reported in the 2007-2008 period. There were 26 of them that self-described as being pilot or feasibility, and really just showing how the various aspects of a clinical trial are reported in pilot studies, with sample size calculations being only done in about a third. Hypothesis testing was quite common. The randomization process really was focused on the pilot trial as opposed to the feasibility studies. They distinguished between the two in this study. Blinding was not a common feature in these studies. Control groups were common. The vast majority concluded at the end that further study was needed or was suggested based on the results of the pilot. And largely speaking, these were small studies with a median number of about 76 participants overall. Ultimately speaking, I genuinely believe that funding agencies are looking for pilot data. They're looking for justification to fund the larger trial, and that the pilot data itself really does strengthen, I think, the full grant application. As a grant reviewer, I'm very much looking for some understanding of how the authors are able to demonstrate the ability to achieve what they've set out to do. I really think that this has become the norm or the expectation. I think the bar has been set. And although historically, and we still believe that it is unethical to conduct underpowered studies, this would be conducting an RCT with the intention of demonstrating some clinically meaningful outcome, but being underpowered to do it. I would suggest that a well-constructed pilot trial is not meant to do that at all. It is really powered to demonstrate the feasibility of doing the larger study, such that I think it's unethical to embark on a large, costly trial that's destined for failure, such that one, I think, is highly justified in piloting the larger trial, even though it's being conducted as a mini RCT in quotation marks. The intentions of this study is really around determining the ability to succeed in the future trial. And I think as long as we are transparent about this, both with our ethics boards and with patients and families as they are consenting into these procedures, that the results of the pilot trial may not ultimately affect clinical management of patients, certainly within the trial, but may help inform a powerful and meaningful trial in the future to ensure that we are providing the best care possible for our patients. So limitations and pitfalls, then really there is risk of misinterpreting the results if we are applying hypothesis testing to clinical outcomes rather than feasibility outcomes. The scope creep of this efficacy testing is very real, that we may wrongly place emphasis on the statistical significance of an underpowered study rather than focusing on the feasibility metrics that it's intended to do. and that it can be dangerous to try and use a pilot study to estimate treatment effects because you're often working in a highly focused, often biased sample that may differ in the larger trial. And then it's really important to clearly state the aims upfront, know the limitations, and have clear criteria on what determines the success of the trial. So I'll jump into a couple of examples just to illustrate maybe a bit what we've been talking about. And so I'll talk about three trials, the REVISE trial being the first, and I'll use this as an example of what I consider to be an external pilot RCT. And so for those who aren't familiar, REVISE is a large international trial that was reevaluating the use of PPIs, so proton pump inhibitors, to decrease stress erosions in patients with positive pressure or mechanical ventilation in the intensive care unit as a GI prophylaxis. And so PPIs had kind of become the standard of care based on old data, and REVISE was really looking at whether or not in the modern era of ICU management and how we manage patients, whether the risks of a daily PPI in all comers really was still necessary. This was led by Deborah Cook and many others. And for those of you that know Deborah Cook or are familiar with any of her work, know how thorough she is and comprehensive. And so in the true model of the Canadian Critical Care Trials Group, this REVISE RCT, which is this red middle box to the sort of middle right of your screen, is the large RCT, but it is an entire program of work that informs that trial. And so to the left of everything in red is really all of the pilot work that informs the large RCT, inclusive of the pilot RCT, which we'll talk about here. And so the pilot protocol was published and really was set out to pilot the larger RCT. So looking at pantoprazole, one of the PPIs versus placebo, and this was a blinded study, and was really meant to evaluate the feasibility of performing the larger RCT. This was most certainly going to be a large study that was likely to be multinational. And so the pilot RCT focused on 90 patients to be able to determine the feasibility of various outcomes across many centers. So 8 in Canada, 1 in Saudi Arabia, 1 in Australia. The feasibility outcomes of the study was focused around the consent rate, where success was deemed 70% or greater, recruitment rate, where the goal was to be able to determine or demonstrate at least 2 patients per center per month. And the 90 patients target for this trial was focused around that. And there was a measure of protocol adherence, again, with success deemed to be 80% or higher. They also intended to capture the clinical outcomes that were proposed to be the primary outcome and secondary outcomes of the larger study, and that being of clinically important GI bleeding, and then secondary outcomes of overt bleeding, infection rates, which were thought to be higher with PPI use, lengths of stay, and mortality. And this study was funded with the PSI grant, or Physician Services Incorporated grant. This is an Ontario grant and a number of local grants across the various participating centers. So seed funding really to support the pilot. The pilot was successfully run, and in the end, although intended to be run as an internal pilot, there were a number of factors that contributed to the decision to report it separately and to run it as an external pilot. And so the results were reported by group, as you can see in the table 2 here. So a very small trial that reported clinical outcomes and were incorporated as part of a larger systematic review and meta-analysis in this publication. This was ultimately decided because of a number of different factors. This included a few things that were learned along the pilot trial itself, and also based on the fact that during the pilot trial, other studies had been published, including large international trials that changed our understanding of the clinical question. And that ultimately this informed the full trial, the protocol of which was published in BMJ Open, with a planned enrollment of almost 5,000 patients, so a very large international ICU trial examining the same question, so pantoprazole versus placebo. But the external pilot ended up changing the intended outcomes of the large trial, where it was no longer considered appropriate to simply understand if upper GI bleeding was affected by PPI usage, but rather whether it was even safe to do so. And so co-primary outcomes were selected, with efficacy and safety being co-primary outcomes. And this data, of course, used to support grant applications that were successful, several CIHR grants, an NHMRC grant in Australia, and an IHR grant in the UK, in addition to additional PSI funding, and landed a very successful large international trial that was published last year in the New England Journal, and again informed practice in a huge way. An example of a vanguard pilot, I'll use the cycle study. And so the cycle program of work is led by Michelle Coe, who's a PhD physiotherapist out of McMaster, again, a Canadian Critical Care Trials Group study, also following a programmatic plan of work. And she's been very clever in her naming of her various studies, all of which have led up to the large RCT or the cycle RCT, but a number of pilot work and ultimately a pilot RCT and then a vanguard RCT that fed into the cycle RCT, and a few more studies still to come from that, with economic evaluations currently underway, and KT work. So the cycle pilot protocol was published. So the pilot RCT was really aimed at understanding the complex intervention, which was the use of an ergonomic cycling device that attaches to the foot of the bed of an intensive care unit patient who's on mechanical ventilation. So a very complex cycling intervention that was added to usual physiotherapy, and compared to the standard of care physiotherapy. And the goal of the pilot was really to evaluate the feasibility of performing these measures in the intentions of conducting a large RCT in the future. They defined a sample size of 60 patients and felt that this needed to be demonstrated across many centers because of the complexity of the intervention, and planned to do so at 7 Canadian centers, with feasibility outcomes a priori defined as recruitment, so 1 to 2 patients per month, protocol violation rates, and they deemed success if violations were less than 20%. Outcome measurement ascertainment, so the ability to measure their intended clinical outcome. They wanted 80% ability to do this at 3 different time points after the intervention. And they felt it really important that this be able to be done in a blinded way, and again, defined greater than 80% as being success. They had a full trial outcome plan of a primary outcome of a physical fitness in ICU testing at hospital discharge. And so this was the planned primary outcome of the larger trial, which they captured as part of their pilot study. They published the results of this 60 patient trial as an internal trial. So they presented aggregate data of these 60 patients without unblinded data, and determined that their investigation or their study was feasible, with largely meeting their a priori defined success rates, with the small exception of the intervention being slightly less than intended at 79%. The pilot study really informed a lot of the procedures that were ultimately employed in the larger trial, particularly around the cycling delivery, whereby it became evident that one of the challenges of providing the intervention related to the human resources of the physiotherapists in the ICU, such that although the original plan was to have this as a 7-day intervention, it really wasn't practical to deliver 7 days a week because of the human resources present on the weekends. And so this solicited a fairly large protocol change whereby the intervention was now only going to be delivered 5 days a week. The second major change was that the intended primary outcome of the trial was to be measured at hospital discharge, but it was found that that was too far away from the intervention, such that the patients were receiving the intervention while in the ICU, left ICU, and wouldn't be getting the intervention any longer, but spent considerable amount of time in the hospital. And so the outcome being measured at hospital discharge was probably not reflective of the intervention in the ICU. And so this caused a major change whereby the primary outcome was now going to be measured 3 days after ICU discharge rather than an arbitrary hospital discharge. And so these major changes were rolled into their final protocol. And as a consequence of doing these, they conducted a Vanguard study as part of the large trial. And so they did a run-in phase of the first 40 patients of the intended larger trial to ensure that a couple of things could happen. One, by bringing on a couple of international sites, that they were still able to maintain the same feasibility. And then they added these additional testings at 3 days post ICU discharge and the cycling strategy. And so, again, had set a priori goals as to what deemed success, which were met, and ultimately conducted a very well run complex intervention study that was published last year in New England Journal of Medicine Evidence. Again, highly informed by both an internal and Vanguard trial. And now finally, the Sahara experience, my own study where we conducted what we called an internal pilot. And so our intent was really to look at a very specific patient group. So those patients with aneurysmal subarachnoid hemorrhage, and ask the question of whether or not a liberal strategy of transfusion, so a trigger of hemoglobin of 100 or less, compared to a restrictive strategy, hemoglobin trigger of 80 or less, decreased the combined rate of death or severe disability at 12 months. Again, informed by the trials group, this was part of a large program of research that included population-based and epidemiologic study, patient engagement and patient-centered outcomes, some intervention work, which is the trial at hand, and a bunch of infrastructure and networking work. As it relates to the Sahara question, there was a lot of piloting work done, both piloting studies in what we deemed phase 1 and a pilot trial, our phase 2 work that was really focused around feasibility and our ability to deliver a protocol that could be adhered to by the various centers, all informing the large trial. And this programmatic approach really, I think, bolstered our argument for the need for a trial that I think was very successful in the eyes of the reviewers who ultimately funded our studies. So we took the same question, but ran it in a pilot study aimed at feasibility, and were successful in getting CIHR seed funding through Canadian Blood Services to pilot our study question. And our goal really was to look primarily at our ability to recruit patients, so randomize at least a patient per month per center over the pilot period, because we felt that this was such a small group of patients that this was the minimum we would need to be able to achieve a large trial. And then we looked at a number of secondary objectives around adherence. And so adherence to the threshold that they were randomized to, adhere to what we called our transfusion protocol. And so this was really timely transfusion, that once you passed the threshold, that a transfusion would occur quickly so as to minimize ischemic time below threshold, which was a major biologic plausibility question of our trial. And that we were able to achieve the clinical outcomes that we intended to use as part of the large trial, and determined or stated that 95% follow-up was necessary to achieve a successful large trial. And so we set out on this pilot study where we looked at 5 centers in Canada. We felt that having a multi-center trial was really important to ensure that we could roll out all of the procedures across various centers. We felt that 60 patients was a sample size that would allow that, such that if there were 5 centers participating, a patient per center per month over a year would determine feasibility. And we piloted a number of different eligibility criteria in our protocol. We proposed a schema that was going to look what we thought very similar to the larger trial, whereby we looked at patients with aneurysmal subarachnoid hemorrhage who had anemia, which we defined as a hemoglobin of 100 or less, and that this had to occur reasonably early in their stay. And so we defined that as 14 days, such that the randomization period was really only the first 14 days of their hospitalization, and that patients that became anemic later than that were a different phenotype altogether. And we administered our intervention over the first 21 days because this was a critical period in this patient population, and followed patients out to 12 months. We were very rigorous in our screening of patients. In fact, as part of the pilot, we included all patients who had a hemoglobin of 110 or less and followed those patients prospectively daily so as to not miss when they fell below that 100 threshold for randomization. And so we call these screen eligible patients. And then those that went on to develop a hemoglobin of 100 or less were approached for randomization, of which we achieved 60. We very closely monitored, as I've alluded to at the beginning, the records, screening logs of each of the centers, and really tried to identify the eligible non-randomized patients and why they were being missed as an opportunity for improved recruitment. We had set out a goal rate in gray here as being the feasibility, the minimum feasibility, which largely we achieved. Our actual rate fell a little bit off of the line, but the trajectory of the line actually was fairly maintained. Where we ran into some challenges and why we came off that line, as you see in this figure, related to onboarding challenges of certain centers and challenges with access to blood supply. And so this identified very clear areas where we could focus our efforts in trying to maintain the targeted recruitment rate, which ultimately in the pilot was 1.2 patients per center per month. We were able to scrutinize the baseline characteristics presented in aggregate, so we didn't look at these in subgroups, but were able to determine that in red, these patients were all but one identified in a high acuity unit, and this allowed us to really refine our screening protocol such that rather than screening patients across the entire hospital, we could really focus our efforts to just the ICU or the screening unit. And so this was a huge resource win for the trial. We were able to demonstrate that the transfusions were happening according to our intended protocol, with median pre-transfusion hemoglobin levels and interquartile ranges reported. And we were able to even demonstrate without statistical significance because of the low numbers, but that our intended protocol did demonstrate separation in the two patient populations. And that if we look at time zero being hospitalization rather than randomization, we see that separation here is occurring between day 2 and day 3. And this turns out to have been the median day of randomization. So we were able to demonstrate in the pilot that not only then was separation occurring right after randomization, but that randomization or patients were eligible very early in their course in hospital by day 3. We could take this data further and looked at when the transfusions were occurring, and we could look at this either as day from presentation or day from subarachnoid hemorrhage or day from randomization, and see that the vast majority of the interventions were occurring early on in the study, mostly within the first 7 days, and largely within the first 2 weeks. Even though this was a 21-day intervention, the vast majority of the resources were being used early on in the study, and likely reflective of the trajectory of the patients. We very closely monitored adherence and demonstrated very high adherence, over 95% with respect to overall transfusion allocation, so restrictive and liberal. And we looked at time to transfusion, which we viewed as being very important in the context of the larger trial. We also looked at our outcomes, which we had excellent follow-up rates, and looked at the outcomes overall in aggregate, which I show in red here, and demonstrated a poor functional outcome rate of 35%, which we had used as our power calculation for the larger trial. We ultimately were able to enroll as we expected. We were able to show good adherence to the protocol and adherence to the allocation, and our ability to achieve outcome assessments even at 12 months, which really supported the application. A few additional takeaways that we got from the pilot was that blinding the outcome assessors was a human resource challenge for each of the centers, and this allowed us to centralize the outcome assessments in the larger trial. We were able to trial our CRF, which we initiated in paper format, and we're able to do this before we went through the large expense of digitalizing this and becoming electronic. And so we were able to make a lot of the changes that we learned through the pilot before the expenditure of the ECRF, which is really in the tens of thousands of dollars. We were able to refine the procedures as it relates to the CRF. We found it helpful for REB, who struggled with the fact that this wasn't really a transfusion trial, but a transfusion trigger trial. And so we were able to establish relationships with the REBs, which facilitated the upping and going of the larger trial. We were able to get patient partners through the pilot study, which again strengthened the overall experience of the trial. And we engaged a DSMC as part of the pilot, and we're ready to go with the larger trial. All of these things were deemed as strengths in our ultimately successful funding at CIHR and the MRFF. So our internal pilot was funded through CIHR. We used that to resubmit to CIHR, who ultimately funded the larger RCT, and did a secondary application in Australia to the MRFF, who funded a second coordinating center out of Australia, and again, largely informed by the results of the pilot, particularly around the human resource need of having a second coordinating center in Australia. And so the pilot really did help inform this. We made some significant changes to the overall protocol in that we only screened for 10 days based on the experience of the pilot. We made some changes to the eligibility criteria overall, particularly how we defined aneurysmal subarachnoid hemorrhage and made that workable for the various teams. And I've already alluded to the 10-day rather than 14-day changes. Let me skip over this. We determined, because of our eligibility criteria, that this was certainly going to need to be international. And so we went from 5 centers to 23 centers and included those in Australia and in the US, which were really key in our ability to successfully deliver a trial. And we were able to substantiate our original sample size calculation based on the aggregate results of the pilot, substantiating a sample size of 740, which ultimately went on to the successful Sahara trial, which we just published a few months ago in New England. So I'd summarize by simply saying that I think pilots can take various different forms. There is some interchangeable aspects of these, but I think of them as standalone, as part of the main trial or as a run-in phase, and how we create these I think really will dictate how we incorporate the results into the either final RCT or how we present the results overall. We've kind of walked through three different examples of how that is. And that as it relates to clinical studies, pilot trials are really around assessing feasibility, safety, and acceptability of an approach to inform the larger study. It really is the trial run, if you will, of the larger study, and gives the opportunity to test logistics and some of the methodological issues that we anticipate, and helps refine your protocols to ensure a successful trial. What it isn't, or what it shouldn't be, is about testing clinical hypotheses about the efficacy of an intervention, and really shouldn't be powered towards these. And highlighting here just a couple of advantages and disadvantages as outlined by Arnold et al. Around why a pilot is helpful, and how it can be disadvantageous or misleading. And just recognizing the time, I think I will leave that for review. A couple of articles I've used, and open up for questions.
Okay, Shane, thank you so much. That was excellent. Exactly what we were hoping to have presented on this topic. We are a little short on time. I'll just ask quickly if anyone in the audience has a question, if you'd like to raise your hand or just start speaking. And if not, maybe I could quickly jump in with a question then, Shane. I think it was very useful, I think, for you to kind of break down the three types of pilots. I think, the argument for doing a pilot at all, I think it was very convincing. But in terms of choosing whether to do an internal or an external or a vanguard study, as a rule of thumb, would you say that, most early investigators, who are just first getting started, really would be needing to do an external pilot, because they just don't have the funding to roll it into the larger trial, and unless they're doing something very, very operationally complicated, it would not be doing a Vanguard?
Yeah, I think I mean, in my opinion, the Vanguard is really um is the most unique, I think, out of the various pilots, and I think is the harder sell, right? If you were using the Vanguard to try and get funding, you would have to have a pretty well established research enterprise, I would think, to be able to convince a granting body to provide the funding. I think it is a bit more ambiguous between the external and the internal trial. And so I think funding will always be a challenge. And as researchers, we just get by, right? We gather the funds that we can, and get moving. I think that the distinction really for me in the internal and the external comes to what you learn in the pilot itself. If you think that you've got a study that is ready to roll, then an internal pilot as a design with feasibility metrics makes a lot of sense to me. And if you are learning sort of very consequential things along the way, you can certainly still choose to make this a standalone piece of work, as an external pilot. Take what you've learned from that, and turn that into benefit for the larger trial. And so I feel like it is a bit gray. It can be a bit gray between the internal and external, and I think I've demonstrated that a bit in the examples provided, where the revised RCT became an external pilot that was examined and looked at clinical outcomes, although that wasn't the original intention.
Okay. Thank you so much. Okay, we're just past the hour. So I'm sure if anyone else has questions, Shane, you would entertain them if you
Yeah, anytime.
by email, but we'll probably wrap up now. Again, thanks everyone for coming out and attending the series. It's a reminder that next month,